this is the second part of the concept of electricity, and of course the part that will base on the arrangement of the resistor in circuit and arrangement of the cell in circuit. Now, our resistor can be arranged in series. When we say series, we mean when we arrange our resistor side end to end. That is when the end of one is joined with the end of the next one. That is, if you have resistor like this is one resistor, then we use wire to connect it with another one. Then you can still use it, depends. So let's assume that we have three resistors in the circuit. So if this one is resistor 1, resistor 2, and resistor 3. So what will now be the effective resistance in the circuit? So since they are in series, they are joined end to end. So we are going to find the effective resistance. Sometimes we call it effective resistance or total resistance in the circuit. We now say total resistance in the circuit is equal to R1, that is resistor 1, plus R2 plus R3. If our R1 is 3 ohms, and this one is 2 ohms, and this one is 3 ohms as well. So it means the total resistance in the circuit is equal to 3 plus 2 plus 3. So which will give us 8 ohms. That is that about resistor in series. Now, we can still arrange our resistor in parallel. So if our resistor and is parallel, we say they are arranged side by side. Side by side. That is, if we have one like this, then we have another one, we have another one. So we join the three together with what? Wire. This. We can determine the total resistance in the circuit. In that case, we have used certain formula. So, if this one is R1, R2, R3, therefore, the total resistance in the series, in the circuit, this is parallel connection. If they are joined end to end, side by side. If it is end to end, we call it series. But if it is side by side, we call it parallel. So in the case of parallel, we have 1 over RT, where RT is total resistance in the circuit, is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So if our R1 is 3 ohms, and this one is 2 ohms, and this is what? 3 ohms as well. In that case, it means our total resistance in the circuit, it will be what? 1 over 3 plus 1 over 2 plus 1 over 3. Then you look for the LCM. The LCM is 6. This one, that is 2 plus 3 plus 2. Therefore, 1, don't forget to write 1 over RT is equal to, you add this one together, which will give you what? No, this one is 3. 2. Okay. It will now give us 7 over 6. Now, where students normally make mistake is this. They will just convert this one to decimal, and we assume that they have gotten the right answer. It's wrong, because what is here is not R, it's 1 over R. So in that case, it's very simple. You can easily make cross multiplication and get your answer. Or, since this one is what? Inverse of R, you find the reciprocal of this. Therefore, RT is equal to 6 over 7 ohm. You convert it to decimal with the aid of your calculator, which will give you, I think, a 0.8 or 9. So that is that about resistance in series and parallel. This one is parallel, the previous one is what? Series. Now let's go to the cell. Then before we go to the arrangement of cell in series and parallel, do you know we can combine the two together? We have some circuit that will combine the parallel and series together. For instance, you can have it like this. This one, then this one, join together, then this one, then this. Now this one, like this. So what it just means, if this one is 2 ohms, let's say 3 ohms, 3 ohms. And if you are looking for effective resistance or total resistance, since this one is in series, leave it like this. The one in parallel, solve it first. You now say 1 over RT within this area is equal to 1 over 2 plus 1 over 2. So the LCM is what? 2 over, LCM is 2. So at the end of the day, you are going to have 1 over RT is equal to 2 over 2, which is equal to 1. So when you find the reciprocal of it, this one means 1 over 1. Reciprocal of 1 over 1 is still what? 1. Therefore, RT is equal to 1 ohm. So I combine this one together to give one of them. The circuit will now become this. So this one is combination of this, which will give me what? 1. Then this one 3. Then this one 3. Therefore, the total resistance now, RT, since they are now in series, should now give me 1 plus 3 plus 3, which is equal to 7 ohm. That's all. So we can have the combination like this. Now let's go to cell. The cell can be in series and it can be what? Parallel. That one is very simple. When you have cells in series, like we have this, one battery, we have another one, we have another one. If this one is 3 volt and this one is 3 volt, the total resistance, total voltage in the circuit will be 3 plus 3 plus 3, so which is equal to 9 volt. But what of if you now arrange it in parallel? Arrange your battery in parallel, what will now happen? So in that case, you have it like this. What is total resistance? So total voltage in the circuit. If this one is 3 volt, do you believe that you are just wasting this and this, or this and this, or this and this? It's only one of these 3 battery that is working. The rest are just wasting. That's why it's not good, it's not advisable to arrange battery in parallel. The battery must be arranged in series. So the total resistance, total voltage in this circuit now, 50 is equal to 3 volts. So the best way of arranging our what? Battery in the circuits is what? Series. So that is the conclusion of the class for today.